going to take a look at important points to remember related to end behavior of some common functions that you will see. So let us say we start with the very basic first functions, which are going to be y equals positive x squared, or y equals positive x to the power of 4, or y equals positive x to the power of 6. Now, the common thing about all these three functions is that they all have an even power. The other common thing is that their leading coefficient, this number, is positive 1 or positive. So whenever you have functions like these, which are even functions and their leading coefficient is positive, they are going to be up and up functions. That means on the left hand side and right hand side, they will always be, the end behavior will be up on the left hand side, up on the right hand side. So this is something to remember. The degree, I repeat, of all of these three functions is an even degree. Hence, these are even functions with a positive leading coefficient. So the 2 points are that these are even functions because the degree is even number. And the other point is that they have a positive leading coefficient. LC is the leading coefficient. So whenever this happens, these functions will always have an up and up end behavior. So let us write down what I just said now as our important note-taking point. If we have a polynomial function with even degree and positive leading coefficient, the end behavior will always be up and up. So that is something to remember. We are taking a look at polynomial functions. Another important point is even. Their degree is even. So their end behavior will always be up and up. So that is something to remember. Now we are going to take a look at the next screen. We are going to take a look at functions which do not have a positive leading coefficient. So what will those functions look like? Those functions will look like y equals negative x squared, or I can say negative 1x squared. Y equals negative 1x to the power of 4. Y equals negative 1x to the power of 6. Now there are more examples like this with even powers, but here what is the main idea? The leading coefficient is negative. This is the leading coefficient, and leading coefficient. Another important point of note taking is that they have even powers. Hence, these are even functions. So again, the thing is that these are even functions. That means they are symmetric about the y-axis. So they are going to be symmetric about the y-axis. And then the other point is that their leading coefficient is negative number. So they are not positive numbers. Now, such type of graphs, all the time whenever you graph them, you will have a down and down graph. So it's going to be on the left hand side a down graph and right hand side also down graph. So let us, whatever we discussed, let us write it down as our note-taking point. Even exponent and a negative coefficient functions and behavior is down and down. So this is something important to remember. The exponent is even, or the degree is even. As you can see, these are even degrees here. And negative coefficient, negative leading coefficient actually. So negative leading coefficient, what is a negative leading coefficient? This is the negative leading coefficient here, -1, -1, and -1. Of the functions, the end behavior will always be down and down. So that is something to remember. Here also it is going to be